Equations, Formulae and Calculations, Part 3. Our learning objectives are to find that the mole is the unit for the amount of substance. Mole can be abbreviated as mol, M-O-L, ده اختصار لكلمة mole. Calculate the reacting masses using experimental data and chemical equations. The formulae of some compounds are obtained from experiments, and to know the difference between empirical formulae and molecular formulae. Calculating some formula masses. Find the relative formula mass, Mr, for magnesium carbonate. They give you the formula MgCO3 and they give you Ar, the relative atomic masses of carbon 12 and oxygen is 16, magnesium is 24. This formula means that magnesium is one atom, carbon one atom, and there are 3 oxygen atoms in the formula or in the molecule. What do? You multiply the number of atoms times the relative atomic mass. So it is 24 plus 12 plus 3 times 16. And you do the multiplication first, then add to 12 and 24. The answer is the relative formula mass is 84. Let's take another example. Find the relative formula mass Mr of calcium hydroxide, and the formula is CaOH between 2 brackets 2. The 2 is multiplied times these atoms. So we have 2 oxygen atoms and 2 hydrogen atoms. Again, you are given the relative atomic masses. What do? You multiply the number of atoms times the relative atomic mass. So 40 plus 2 times 16 plus 1. OH 16 plus 1 times 2. And the answer is, you do the multiplication first, then you add, and you the result is 74. The relative atomic masses are given in problems. You can also get them from the periodic table. This is part of the periodic table, sodium Na. You have here 2 numbers, a small one and a large one. Which one is the relative atomic mass? It is the larger number. This is the relative atomic mass. So for sodium, it is 23. You approximate the number. هتقربوا لغاية ما يبقى عدد صحيح. 23, 24 for magnesium, and the relative atomic mass for potassium is 39. The relative atomic mass for calcium is 40. It is the larger number of the two, and you can get it from the periodic table as well. Let's solve another problem. Find the relative formula mass of copper 2 sulfate crystals. The crystal's formula is CuSO4.5H2O. When some substances crystallize from solution, water bonds chemically with the salt. For copper sulfate, the water of crystallization is 5 water molecules bonded chemically with 1 molecule of copper sulfate. Again, you are given the formula and you are given the relative atomic masses of the elements. How do you solve this problem? First, you find the relative formula mass of 5 molecules of water. 2 times 1 plus 16, which is 18, times 5. Now you have 5 times 18, which is 90. This is the relative formula mass of 5 molecules of water. Then you find the relative molecular mass of copper sulfate. It is 63.5, this is copper, plus 32 sulfur, and plus 4 times 16 because you have 4 oxygen atoms. Do the multiplication first, then add to 32 plus 63.5, and the answer is 159.5. Now add both of them, 90 plus 159.5, and the answer is the crystal copper sulfate plus 5 water molecules has a relative formula mass of 249.5. Now find the relative formula mass of iron sulfate crystals. Iron sulfate crystals are bound chemically with 7 molecules of water. And this is iron sulfate, 1 iron atom, 1 sulfur atom, and 4 oxygen atoms. And we are giving AR to calculate from these. So now 56 for iron, 32 for sulfur, 4 times 16 for the 4 oxygen atoms, plus 7 molecules of water. We have 2 hydrogens and 1 oxygen, which is 18 times 7. Then we do the addition and find the answer. Using the relative formula masses to find the percentage composition. Let's take this problem. Find the percentage by mass of copper in copper 2 oxide, CuO. Now, the relative atomic masses of oxygen is 16 and copper is 63.5. First thing, find the relative formula mass of copper oxide by adding the masses times the number of atoms. You have 1 copper atom, 1 oxygen atom, therefore it's 63.5 plus 16, and the MR equals 79.5. We need to find the percentage of copper by mass. So it is 63.5 divided by the 79.5 we calculated, and because we want it as a percentage, we multiply times 100. So 79.9% of copper oxide is copper by mass, and the rest, which is about 20.1%, is oxygen. Now another problem. Find the percentage by mass of oxygen in sodium carbonate. This is the formula of sodium carbonate, NaCO3, 1 sodium atom, 1 carbon atom, and 3 oxygen atoms. And the relative atomic masses are given: sodium 23, carbon 12, and oxygen 16. The first step is to calculate the relative formula mass for sodium carbonate. So it is 23 plus 12 plus 3 times 16, and the answer is 106. We need the percentage of oxygen by mass, and because there are 3 oxygen atoms, we are going to multiply 3 times 16, divide by MR, then multiply times 100. And the answer is 45.3%, and therefore the mass of oxygen in sodium carbonate is 45.3%. Calculations using moles. How do you interconvert a mass in grams into moles for a given substance? We have a rule. The rule says that the number of moles equal the mass in grams divided by the mass of 1 mole. We are going to put this rule into a triangle. The number of moles equal the mass in gram divided by the relative formula mass, which is also the mass of 1 gram. If we know the mass and we know MR, we can find the number of moles by dividing the mass divided by the mass of 1 mole. If we know, if we don't know the mass and we want to find the mass, we multiply the number of moles times the relative molecular mass, and we get the mass in gram. If we want to know the relative molecular mass, we divide the mass divided by the number of moles and we get MR. So how do you use this triangle? The value which you want to get, put your finger on and see what happens to the other two. For the mass, you multiply these together, and for MR, you divide these together, and for the number of moles, you divide the mass divided by MR. Now let's solve a problem related to this rule. Find the mass of 0.2 moles of calcium carbonate, CaCO3, and you are given the relative atomic masses of the elements. Now you have the number of moles and you need the mass. So you multiply the number of moles times the relative formula mass. So the first step is to get the relative formula mass. How do you calculate it? The relative formula mass is 40 plus 12 plus 3 times 16. You do the multiplication first, then the addition. The answer is 100. The relative formula mass is 100. Therefore, the mass of 1 mole, is 100 grams. We need the mass, the number of moles times the relative formula mass, which is 0.2. It is given here in the example, multiplied times 100, and the answer is 20 grams. Find the number of moles in 54 grams of water. What's given here? They give you the formula H2O in order to be able to calculate the relative formula mass. And you have the mass and you want the number of moles. What do you do? First, find the relative molecular mass. 2 times 1 plus 16, which is 18. The mass of 1 mole equal 18 grams. The number of moles is the mass given here in the example divided by the relative molecular mass, which is 18. 54 divided by 18. Now you have 3 moles. And you can also calculate it in a mental way. If the mass of 1 mole is 18 grams, now 54 is 3 times 18. Therefore, you have 3 moles. Moles and Avogadro constant. 1 mole of any substance has 6 times 10 to the power 23 atoms. That's a large number. It means 6 and 23 zeros in front of it. 1 mole of carbon is 12 grams. And it contains 6 to the times 10 to the power 23 atoms, means 6 and 23 zeros in front of it. This number, 6 times 10 to the power 23, is called Avogadro's number or Avogadro's constant. 1 mole of magnesium has 6 times 10 to the power 23 atoms, and the mole equals 24 grams. 1 mole of water contains 6 times 10 to the power 23 molecules, and its mass is 18 grams. This is why chemists use moles. If you know the number of moles, you can find the number of particles. You multiply the number of moles times Avogadro's number. So you can know the number of particles, whether atoms or molecules. This way you can find out how much of a substance can react with another amount of substance. Formulae. The formula of sulfur dioxide is SO2. It means that one molecule has one atom of sulfur and two oxygen atoms, or 1 mole of sulfur atoms and 2 moles of oxygen atoms. Now, if a compound contains 0.4 mole of manganese and 0.8 mole of oxygen, then it has 1 manganese atom and 2 oxygen atoms. The formula of this compound will be MnO2. These are called empirical formulae. We get them from experiments. In an experiment, we found that a compound is made of 0.2 mole calcium and 0.2 mole oxygen. Then the formula is CaO, calcium oxide. This is because there are the same number of calcium and oxygen atoms, Ca1 and O1, but we don't write the 1. This formula, CaO, is called the empirical formula. It shows the simplest whole number ratio of the atoms in a compound. The ratio here is 1 to 1, and the ratio here in manganese dioxide is 1 to 2. So the empirical formula shows the simplest whole number ratio of the atoms in a compound. There is another formula which is called the molecular formula. The molecular formula shows the actual number of atoms in the compound. Now, the molecular formula can be the same as the empirical formula, such as calcium oxide. The molecular formula of calcium oxide is CaO, the same as the empirical formula. But the molecular formula can also be a multiple of the empirical formula. The empirical formula of hydrogen, the ratio between H and O is 1 to 1. So hydrogen peroxide, the empirical formula is HO. But the actual one, the molecular formula, the real one is H2O2, because in a molecule there are 2 hydrogen atoms and 2 oxygen atoms. Finding out empirical formulae. How we find out empirical formulae? To find out the empirical formula of copper oxide, you need to find the number of copper atoms and the number of oxygen atoms in a molecule of copper oxide. How do we do that? Let's solve this problem. You have a compound that contains 1.27 gram of copper and 0.16 gram of oxygen. Calculate the empirical formula and you are given the relative atomic masses of copper 63.5 and oxygen 16. How do you do that? You are going to make a table. In the table there are 2 columns, one for copper and one for oxygen. Write the masses given to you in the example. 1.27 for copper and 0.16 for oxygen. We have to find the number of moles. The number of moles equal the mass divided by the relative atomic mass. So it is 1.27 divided by 63.5 given in the problem. And for oxygen, we divide the mass divided by 16. The answer for copper is 0.02. And for oxygen, it is 0.01. So now we have the number of moles of copper and the number of moles of oxygen. You are going to divide the number of moles by the smaller number. The smaller number is 0.01. So you divide both numbers with the smallest number to find the ratio. 0.02 divided by 0.01, and this gives me 2. 0.01 divided by 0.01 gives me 1. So the ratio of copper atoms to oxygen atoms is 2 to 1. So I have 2 copper atoms and 1 oxygen atom. I put 2 next to the copper. This means that the empirical formula is Cu2O. Now, why did we put oxygen 16, the relative atomic mass, and we didn't use 32? The relative atomic mass of oxygen atoms is 16. So you use 16. But the relative atomic mass of an oxygen molecule is 32. 2 times 16. Let's solve another problem. In this problem, there is a compound that contains 0.78 gram of potassium, 1.10 gram of manganese, and 1.28 grams of oxygen. All of these are masses. They want us to calculate the empirical formula, and they give us the relative atomic mass of potassium 39, manganese 55, and oxygen 16. How do you solve this problem? Again, you make a table and you start with the masses. You put the masses of potassium, manganese, and oxygen, which are given to you in the example. Then you find the number of moles. The number of moles is the mass divided by the relative atomic mass. So it is this mass divided by the relative atomic masses given here. And this is how you find the number of moles. The number of moles of potassium is 0.02, and for manganese also 0.02, and for oxygen it is 0.08. So now you divide by the smallest number. The smallest number is 0.02. In this, when you divide potassium by the smallest number, you get the ratio. The ratio here is 1. And for manganese, it's also 1. But when you divide 0.08 by 0.02, you get 4. So the ratio of moles is 1 mole of potassium, 1 mole of manganese, and 4 moles of oxygen. And therefore, the empirical formula is KMnO4. 1 is not written, that's why it is KMnO4.